Something unusual has entered the range of the world's telescopes. What they are detecting and analyzing does not follow normal patterns. The object known as 3-Ice Atlas has become one of the most puzzling interstellar visitors ever observed. Its strange emissions, complex flight path across several planets, and unpredictable behavior have captured the attention of astronomers across the globe. For the first time, an interstellar object is showing chemical and physical signs that do not match anything previously recorded. Observations from multiple observatories reveal asymmetrical forms, variable brightness, and a loss of mass that cannot be explained by the usual processes seen in comets or asteroids. These findings have led experts to consider new theories that could reshape the current understanding of interstellar matter and the formation of the solar system itself. Space agencies such as NASA and the European Space Agency have released limited data, while other national observatories remain silent. Adding to the growing mystery, the limited information available suggests that Atlas is not traveling alone. Researchers predict that other interstellar bodies may be following a similar trajectory approaching the inner solar system in the coming years. As images and spectral data accumulate, astronomers are realizing that this is not a typical comet. The object's chemical composition, its changing light curve, and its interaction with solar radiation all show signs that it does not fit any known category. Detailed images taken from Hawaii using the Keck and Gemini telescopes have shown that Atlas does not behave like a regular cometary body. Its emission spectrum displays strong traces of nickel, but little to no detectable iron within current sensitivity limits, a combination rarely, if ever, seen in nature. The phenomenon of nickel without iron suggests a chemical refinement process unknown in natural space environments. Somewhat similar to the controlled separation of metals used on Earth, the nickel emissions extend over hundreds of kilometers, forming a narrow antitail that points towards the Sun instead of away from it. Unlike most comets, which produce a long, bright tail of dust and gas, Atlas shows almost no visible dust trail. Its mass loss rate has been estimated at around 150 kilograms per second. It's composed mostly of carbon dioxide and carbon monoxide with only a minimal amount of water vapor. The absence of ice-based emissions and the dominance of heavy gases make it fundamentally different from other known objects. This unique combination of chemical, behavior, and structural irregularity indicates that Atlas may not have formed in the same way as typical comets and that it could have originated in an entirely different stellar system. Upcoming missions may soon shed more light on this mystery. To spacecraft. NASA's Europa Clipper and the European Space Ace Hero mission are predicted to pass near the possible path of Atlas's tail. If this alignment occurs, it could offer the first chance to study the material surrounding an interstellar object at close range. However, he lacks the instruments needed to collect direct samples. While Europa Clipper's ability to record data depends on both operational timing and the influence of the solar wind, the potential observation windows fall between late October and early November 2025, around the time Atlas reaches its closest approach to the Sun, known as perihelion. If both missions fail to collect data, the European JWST probe, orbiting further from the Sun, may still be able to observe the comet from a distance. Scientists consider this a rare opportunity that may not happen again soon, a chance to study matter that comes from beyond the solar system. Success will depend on precise coordination, technology, and timing. Atlas has already challenged many long-held assumptions about interstellar objects. Yet its discovery is likely only the beginning. Activation of new detection systems such as the Vera Rubin Observatory in Chile is expected to reveal 1 or 2 interstellar objects every year. What once appeared as a rare cosmic event could soon become a regular observation. To prepare for this, ESA is developing the Comet Interceptor mission. The plan is to position a probe in a stable orbit where it can remain on standby. When a new interstellar object is detected, the spacecraft will intercept it and record direct measurements. The goal is to study such visitors before they pass out of range, something that has not been possible with past interstellar comets like 11 Imoama and 2 Boreas each. Of these objects provides valuable information about the materials and processes that exist beyond the solar system. Some may carry fragments of ancient planetary cores or elements from long-destroyed worlds. Others could contain organic molecules that once played a role in forming life. Their high velocities, unpredictable paths, and short observation windows make them difficult to study, but they remain vital clues to understanding the galaxy's chemical diversity. Atlas is currently estimated to be billions of years old, possibly older than the Sun itself. Its nucleus could span several km with a total mass reaching tens of billions of tons. Some estimates place its age in the 712 billion-year range. High uncertainty, meaning it formed before the Sun or any planets in our system existed. Its composition, rich in nickel, cyanide, and carbon compounds, points to a violent origin. It may be the remaining fragment of a destroyed planet from another star system. If the object fragments as it approaches the Sun in October 2025, the resulting debris could reveal further information about its internal structure. Such an event might also show whether Atlas contains solid rock, porous dust, or even hollow regions that have caused speculation within the scientific community. A few astrophysicists have proposed that its density is far lower than expected, suggesting it could be a sponge-like structure rather than a solid body. Atlas rotates slowly, roughly once every 16 hours, and shows almost no measurable gravitational effect on nearby objects. Its low gravity indicates it is either extremely porous or partially hollow. At such low gravity, even a modest jump could send a person drifting upward, a reminder of how little we know about these worlds. So low that a fast-stunning human could theoretically leave its surface if standing on it. While this idea may sound extraordinary, it illustrates how little is known about the physical properties of such interstellar visitors. Despite public speculation about artificial origins, most scientists continue to treat Atlas as a natural object. However, they agree that if it emits unusual radio signals or shows signs of structured fragmentation, it could represent an entirely new class of celestial body. As of now, there is no confirmed evidence of any artificial characteristics, but the irregular rotation, chemical imbalance, and lack of a standard comet tail continue to puzzle researchers. The importance of Atlas lies not only in its mystery, but also in what it represents. It demonstrates that our solar system is open to interstellar traffic, cosmic travelers passing through from distant regions of the galaxy. Every such object provides an opportunity to study the material history of other stars and the processes that form them. With each discovery, scientists gain insight into how common or rare life-bearing planets might be elsewhere in the Milky Way. Photographic evidence supports the ongoing investigation. Images from the Gemini North Telescope in Hawaii show the object's changing color and brightness. VT spectroscopy first reported nickel and cyanogen. Later, JWST infrared data were consistent with those detections. Data from the ExoMars Trace Gas Orbiter captured its movement across the Martian sky, confirming that it reflects sunlight differently than ordinary comets. Additional data from the European Southern Observatories VT in Chile reveal faint traces of a gas tail, though its structure remains unclear. As Atlas approaches the Sun, scientists expect its appearance to evolve rapidly. Thermal stress could cause parts of its surface to collapse, releasing new jets of gas and dust. If the object splits apart, those fragments might provide direct clues to its interior composition. Researchers are preparing to track these events using both ground-based telescopes and space probes already in flight. What is certain is that Atlas is no ordinary comet. Its peculiar combination of chemical imbalance, structural irregularity, and unknown density makes it one of the most scientifically valuable discoveries of this decade. It forces researchers to rethink the definition of comets, asteroids, and interstellar debris, blurring the lines between them. Whether it proves to be a porous natural fragment or something entirely new, ATLAS will remain an important case study in understanding the diversity of matter in the universe. Each observation adds another layer to the story of how our solar system interacts with material that comes from far beyond it. The continuing investigation may not only reveal the true nature of this traveler, but also open new questions about the origins of planets and the chemistry of life itself. Until the next close approach, astronomers continue to monitor ATLAS with every instrument available. The data being collected will refine orbital models and provide insight into interstellar structure and evolution. Whatever conclusions are reached, the discovery of 3I ATLAS marks a turning point in modern astronomy. A reminder that our solar system is not a closed world, but part of a vast and ever-changing galaxy. Thank you so much for watching all the way to the end. If you enjoyed this deep dive, please smash that like button. Share your thoughts in the comments below, and don't forget to subscribe.